All right, we are moving from surface area of prisms and cylinders to surface area of pyramids and cones. So pyramids and cones are still three-dimensional objects. We're going to start with the word pyramid, so I can give you the definition. Again, if you are filling them in, it'll be quicker. If you're not, you can just fill in some blanks if you need to. That way you can put them in later. Pyramid is a polyhedron. We did talk about a polyhedron in our notes a couple of sections ago, and it's a three-dimensional object that has no curves at all. So you have to have all straight sides to be a polyhedron. Now, a pyramid's a polyhedron in which there is only one base. Prisms have two bases. They're exactly identical bases. Pyramids only have one base because they sit on that one base and then the triangles come up to the top. So pyramids have one base in which the base is a polygon. The base has to have no curves in it. It's got to have all straight sides. The lateral faces. Remember, lateral sides are all the sides around the base. Not the base itself, but everything around the base is the lateral side. The lateral faces are all triangles with a common vertex. So if you look at this picture right here that you have on your paper, this point right there is your common vertex, where they all come up to that one point at the top. They're all going to touch there. That makes it a pyramid. Now, a pyramid has to be closed. You can't have the pyramids come up and have an opening at the top of it. That's not a pyramid. They have to close together. It's got to be a three-dimensional object. So that's why there's a common point where those all touch at the same spot. A regular pyramid has a regular polygon for a base. That's why we call it a regular pyramid, because the bottom shape has all equal sides. That's what regular means. They're all equal. So this pyramid in green right here is a square pyramid because it's got a square for the base. You might have a hexagonal prism or a pentagonal pyramid or whatever. So you have different kinds, but a regular one has a regular polygon for a base. Look at this picture down here. This is not a regular pyramid, because you can tell right away that the base is a rectangle. Rectangles are not regular shapes. In a regular pyramid, all of the triangles will be identical to each other. You'll have same triangles all the way around. You can tell in this one, this triangle is different than this triangle. So it's definitely not a regular pyramid because it does not have a regular shape for the base. So that's the regular polygon. The slant height is different than the regular height. Slant height is the altitude of a triangular face. So if you look at one of your triangles and you get the slant height would be the height of that triangle itself. That's what we call slant height. This line right there is your slant height. This line is your slant height right there. All right, back on. So we got our slant height. These two blue arrows down here are called lateral faces. They're pointing to the two triangles. Triangles are all the lateral faces. The bottom arrow is pointing to the base. Bottom of our pyramid is the base. Now, a lot of times we just want to find the lateral area because we don't need to cover the base. If you've got a pyramid, some toy pyramid in your yard and you want to paint it, you're not going to paint the bottom because it's sitting on the ground. You're just going to paint the triangle. So you're going to use, a lot of times we're just going to use lateral area. Now, slant height is different than the regular height. If I wanted to know the height of my pyramid, I would need to see how tall it stands straight down, right? I wouldn't want to know how long it is diagonally. If I want to know if it's going to fit somewhere, I got to see what the regular height is. So that means I would have to take the top off and put a line straight down to see the regular height. The slant height would be the height up the side of the pyramid. Like if you're climbing up the pyramid, you want to see that. That's the slant height. The letter we use for the slant height is usually a small L. Now, I couldn't do too many small L's very well in my other slides because they look like ones. And see, like this looks like just a straight line. So slant height should be a cursive L. That's kind of what they use. Now let's see, the lateral area is the area of all the triangles in the pyramid. So the lateral area is just where you find the area of all the triangles itself, not the bottom, not the base. The surface area combines the lateral area with the base. So if you put the lateral area together, all the triangles together with the bottom, then you have the whole surface area. So you got your lateral area, you got your surface area for the pyramid. We're going to talk about cones in a little bit. All right, let's move to the next slide here. All right, surface area of a pyramid. To find the surface area of a pyramid, find the area of the base and the area of the lateral faces, which are the triangles. The lateral faces would be your triangles. So the lateral faces would be the area of all the triangles around the outside. So the base is our big B, capital B we use for area of the base, and then the lateral faces would be all the triangles. There is a formula. The more times you write down the formula as you do practice problems, the better chance you'll have of remembering it. And it's very similar to our other formulas, except there's only one B. It looks similar to our other formulas, but the other formula had two B's. And it had PH. This time it's going to be PL. And I would like to put a cursive L up here because that's really what it should be. Because capital L doesn't stand for slant height. But I needed to show you an L rather than just a straight line. I didn't know if you would know what that was. Capital L we usually use for lateral area. So you see capital L, you usually use that lateral area. Small L is what we use for slant height. So your one base, this B right here, represents area of the base, area of base, and this right here is our lateral area. So 1/2 PL, that will give us the area of all the triangles. So the 1/2 PL is your lateral area, and the B is your area of the base. So what if they just said to you, find the lateral area of this pyramid? What would you do then? You would just do 1/2 PL, because you would all you would need is this lateral area. You wouldn't have to add the B to it. If it said find the surface area, then you got to add the B to it to get the whole surface area of the pyramid. So look at the directions carefully to see if it's asking for lateral area or surface area. You can shorten up your work if you're just looking for lateral area. Now this bottom example is asking us to find the surface area. What kind of pyramid is that? It's a square pyramid, because the bottom's a square. We call it a square pyramid. It's a regular pyramid because the bottom is a regular polygon. So we want to find the surface area. We're going to need to use our formula, like this formula, but we're missing the L in this picture. We need to find L. We need to find out the L. So let's see what it would look like. Okay, that's where L would look. That's what we're looking for, that L. Can you see that? It's kind of red. This is supposed to be an L right here. Kind of looks a little like an L. That's your slant height. What does the 8 represent? Let me show you over here on this wall. See this corner right here? That's the 8. This is your triangle on that picture. This side is your triangle, this side is your triangle. You're looking for the middle L that goes up the side of the triangle, not the edge. The edge is longer in a triangle. So this is what that 8 represents. It's where the corner comes. It's like a corner of it. And then the sides of it are the triangles. So that 8 is the corner piece where the two triangles touch. What we want is the exact height of this triangle. It's shorter than the 8. The 8's our hypotenuse. You see the little right triangle right in here? The 8 is the hypotenuse. The L is the long leg. It represents our slant height. So I'm going to push this one and show you what the base of my little triangle is. How did I get a 5? Half of 10, right? You're just bringing this straight down. So you get a 5 here, and you get an 8 for the hypotenuse. So what could I do to find L? Let's use the Pythagorean theorem, right? A squared A squared plus B squared equals C squared. C would be our 8. So there it is right there. A squared plus B squared equals C squared. 5 squared plus L squared would equal 8 squared. Just plug them in. You then solve it, and then you then put your L as your 6.2. So your slant height, which is the height of my triangle, is 6.2. The 8 is the edge where the two of them touch. You don't want that for surface area. You need the slant height for surface area, the L. Now we have enough information to fill in our formula. This formula right here, we want the surface area, which is B plus 1/2 PL. So you rewrite the formula. I would always do that. I didn't actually on this one, but I would rewrite the formula. And then you start to plug in the pieces. The B is area of my base. So that would be 10 times 10, which is 10 squared. The 1/2 times PL, and again, I would put a small cursive L right above this, just to show that that's not a capital L. Capital L really is lateral area. I couldn't get a good cursive L to come out. I think I found one on a later slide, so you can see if you think it is, but yeah. Okay, so the 10 and 4 would be my perimeter, because my bottom has all sides of 10, and there's 4 of them. So there's 4 sides, and they're all 10. So my perimeter would be 10 times 4, which is 40. So I plugged in my 10 squared for my base. 10 times 10 is my area of the base. 1/2 times 10 times 4 is my perimeter. And 6.2 was what we just found for the slant height. Now we just start to simplify. And you get 10 squared is 100. 1/2 times 10 times 4 times 6.2 came out to be 124. Your whole surface area is 224. 224. If you were to look at that board right here, if you were to look at these numbers, could you tell me what the lateral area was just by looking there? The lateral, just the area of the triangle? It'd be the 124. That's my lateral area. This is my base area right here, the 100. So if I just wanted lateral area, I would just do the 124. If I need the whole surface area, I add those two together, I get 224. Yep. Area is square units. Volume is cubic. Volume is what fills it up inside, which we're going to do in the next section. Yeah. I would put it in the box. Yeah. All right, moving on to cone. All right, no, we got to practice one more for a pyramid. Okay, so surface area of the pyramid. What is this pyramid called? Hexagonal pyramid, because it's got a hexagon for the base. Okay, so what we want to do is first rewrite our formula. So surface area is big B plus 1/2 PL. I'll use cursive L there for our slant height. 1/2 plus P plus L, and then you add the base to it to get the whole surface area. That means we want to cover the whole thing. B plus 1/2 perimeter of the base and the slant height. So first thing we need to do is find the perimeter of the hexagon. My base is a hexagon. Do you remember the formula to find the area of a hexagon? Yes, 1/2 times little a times big P, right? So let's write that formula down for our hexagon. A equals 1/2 times little a times big P. That was on our tic-tac-toe Tuesday. I gave you that question on Tuesday, and some of you remember that. 1/2 times the apothem times the perimeter. So let's look at what they gave us. 1/2. Did they give us the apothem of the hexagon on the bottom? They did. They were nice to you. See this little triangle here is an equilateral triangle because it's a hexagon. And that means that all the angles are 60 degrees in this triangle. So when they cut this in half, this is my apothem. From this point straight to here is my apothem. It's right straight to the edge at a 90-degree angle. This is a 30, 60, 90 right triangle. And since the side is 6, that means the small leg was 3. And how do you go from the small leg to the long leg? You just multiply it by radical 3. So 3 times radical 3 would be your long leg. That would be your apothem right there. So it's going to be 1/2 times 3 radical 3. Do we know the perimeter of that hexagon? They're all 6s. How many 6s are in a hexagon? 6. 6 times 6 is 36 is your perimeter. All you have to do is multiply that together and you'll get the area of the base, you'll get the big B. So let me, okay, so your area of your base comes out to be 93.5. So I'm going to bring that down as my big B. So that's my area of the hexagon. They were nice to you. They gave you the apothem. They gave you the side. So the perimeter was easy. The apothem was easy. Times 1/2. You get your 93.5. Now let's plug in the rest of it. We need 1/2. Now do we know the perimeter again? We just found it, right? It was 36. So use that same perimeter over here. And this time we need the slant height. Did they give us the slant height? Yeah. They actually gave that to you as well. They were nice to you again. They gave you the red line as your slant height, so that's an 8 right there. So you're going to bring down the 93.5, and then you're going to multiply 36 times 8 times 1/2. 6 times 8 times 0.5, and I got 144. So check that and make sure. But I'm pretty sure you got 144. That's what I got last year. Now, if I added those two together, you get 237.5 is my surface area, and that would be in square meters. Area is always in square meters. If you looked at the board and they just wanted you to find the lateral area, what would you put? 144. This is the lateral area. This is the area of the bases. This would cover all the triangles. This would cover the base hexagon. All of it together, this 237 covers everything. So that would be a surface area for a pyramid. This was a nice one because they gave you most of the pieces that you needed. And a lot of it's, again, calculator. If you have a calculator, it'll come in really handy on these. Because you plug the numbers, plug them into the formula, and then you just use your calculator to print it out. You good to move? Got it? Okay, moving on. Okay, let's look at the surface area of a cone. Surface area of a cone. You probably hear the word cone, and you probably think ice cream. Maybe. I don't know, maybe not. But, you know, you have those waffle cones. They come to a nice little point at the bottom, and then you chew off the point, and then ice cream comes out of the bottom, you know. That's what a cone is. So we're looking at how much it would be to cover the cone. How much paper you would need to cover the lateral side. You know, they use those little things outside of it to keep your hands cleaner. That would be lateral area. If you wanted to cover the whole cone, that would be the surface area. So the formula for surface area is right there. Pi r squared plus pi rl. And really what that is, it's the same formula we just used. It's one base, isn't pi r squared a base? Area of a circle? The base, the cone is going to have a circular area, always circular base. And then pi rl is the lateral area. Let me rewrite that to show you this if we extended it out. It would be 1/2. Circumference is 2 pi r. And then you have L. Well, how come I shortened it to just pi rl? What did I do? What did I do to the 2? They cross-canceled, didn't they? Didn't this 2 cross out with this 2 right there? So all you had left was pi rl. So it's a shorter formula for us if we just use pi rl. So if they ask you to just find the lateral area for a cone, what do you need to do? Just pi rl. It's that fast. Do pi times radius times slant height and you'll have it. If they need the whole thing, then you add the base to it. In this one, they want the surface area, so that means they want the top formula. They want the base added to it. Okay, so let's see what we got here for this one. Here's my formula. I always like to try to rewrite them as much as possible because they get in there easier when you rewrite it. You remember things a lot faster the more you write it down. So pi r squared plus pi rl. That's going to give you the whole surface area, the base and the lateral. Here's what I would put next. I just fill it in. Once you fill it in, it's all calculator work. Just type it all into your calculator. You'll get your 2 numbers, and then you'll get your surface area, and it would be in square inches. not cubic. We're still looking at surface area. Volume will be next section. So if I needed to cover this cone, I would need 204.2 square inches of paint, paper, or whatever it is I'm covering. What if I just wanted to cover the sides? How much would I need? The 125.7 would cover the sides. The circular base is a 78.5. So you've got your sides here, you've got your base there. That's the area of the circle, and then the sides are the 125.7. Okay, the last page is just a few practice problems. And then I made a mistake on the paper. I'll show you what I did. I mean, I didn't make a mistake. I just put them in the wrong order. So I'll tell you what that was in a minute. But let's do the next three, because they're just practice ones. And it'll help you, I think, when you do your practice problems tonight. If you have these done, it will help you a lot. Okay, so the first two are to find the surface area of the pyramid. So my formula will be S equals 1 base plus 1/2 times the perimeter of the base times the slant height. That's the formula I need for a surface area for the pyramid. I want the P this time, not the C. Perimeter is because it's a polygon. Let's fill in what we know. It's first off, a square pyramid. That tells me that all four sides are 4s. They're all 4 centimeters. So if I want to find my area of the base, what do I need to do to get the area of that square? 4 times 4, right? So 4 squared. So my big B is going to be 4 squared. 1/2. Now my perimeter, I've got a square and they're all 4s. They're 16. 4 plus 4 plus 4 plus 4, or 4 times 4 is 16. The slant height, they actually gave you right here. Slant height is 12. So you can bring this down 16 plus how much? 96. Yeah, you could actually cross cancel the 2 and the 16, and 8 times 12 is 96. And so when you add those two together, you get 112 square centimeters. 112 square centimeters. That would be the entire surface area. Perimeter of the base. Always perimeter of base. Yep. So if I just wanted to cover the sides of the pyramid, how much would it be? 96 would be the lateral, just the triangle. The base is 16. A triangular pyramid. We're going to assume that the triangle is an equilateral triangle. So you got a triangle at the bottom, and you got 3 triangles that come up to the sides. Let me draw the triangle. It says they're all 5 inches. So we're going to draw an equilateral triangle where they're all 5s. And I'm going to rewrite my formula. Big B plus 1/2 perimeter times slant height. How do I find the area of my base? You've got to find the height of that base. You got your 5, and you're going to need a height of the base, because you need base times height divided by 2, right? So what do I do there? That equilateral triangle is the base. And then the 3 triangles are going to come up. It is a 30, 60, 90, because in an equilateral triangle, these would all be 60s, and we cut one of them in half. So we got a 30, we got a 60, we got a 90. The short leg is 2.5, because we cut the 5 in half. So what does the x, my height, have to be then? It's the short leg times radical 3, so it's 2.5 times radical 3. That's going to be my height. 2.5 times radical 3 would be my height. So let's see if we can plug it in here. To get the area of this triangle, I need base of 5 times height, which is 2.5 radical 3, divided by 2. That's going to give me my big base, my big B. Plus 1/2 times, what's the perimeter of my base? If I add my 3 5s together, 15 is my perimeter of the base. That's my P. And then my slant height, they gave me the slant height is 8. So that'd be an 8 right there. So now we're going to get our trusty calculators out. And 5 times 2.5 times radical 3 equals, and then divide it by 2. You're going to get 10.8 for your big B, plus your lateral area is going to be 0.5 times 15 times 8, which is 60. That's your lateral area. That'd be the area of all the triangles. So your surface area then has to be 70.8, and that would be square inches. 70.8 square inches. Okay, I'll leave that there. I'm going to get to the next one so you can actually see it a little better. Okay, find the lateral area of a right cone. Okay, so this time we've got the cone. It's got a radius of 5 meters and a height of 12. So let's try to draw an oval that comes up to a point. And let's draw what we have. We have a radius that's 5. And then we have a height of 12. And what is it asking us to find? Just lateral area. Do you remember the lateral area formula? It was just pi r L. You don't need to add the pi r squared because you're not looking for the base. So it's just going to be pi r L. Now, if you're not careful on this one, you'll miss it right away. Because you'll take the 12 and you'll put it in for L and you'll think you'll have it. But 12 is not L. What is 12? Does it say slant height? No, it says regular height. And what is regular height? How tall is it straight down from the bottom? If I opened up the top and dropped the tape measure down, how tall is that? So the 12 is actually this height. This is 12 right there. What we need is the slant height. Any ideas how I could find that slant height? Pythagorean. You got a squared, you got b squared, you got c squared. So you'll have your 5 squared plus your 12 squared equals your, I'll put L squared because we want to find slant height. So you're going to get 25 plus 144, you get 169, square root it, and you'll get L is 13. Now you can plug them in. You're going to have pi times 5 times 13. So you're going to do pi times 5 times 13. And you get 204.2 for your lateral area. And that would be in square meters. Again, you don't have to find the base on that one. It just asks for lateral area. If it asks for the base, you would just do pi times 5 squared, and you'd have your base. All right, that is it. The rest of them are all practice problems, and I'm going to show you what happened. I messed up in the sense that this was supposed to be the first page of practice problems. This was supposed to be the second page of practice problems, but it got put above the other one. So pretend like these were underneath it. This is number 3 and 4. So you've got 1, 2, 3, 4, and then you got 5, 6, 7, 8, and 9 for your practice problems. Those I will be checking tomorrow, first thing. So when you come in tomorrow, you go to my desk for the sticks. You'll show me the practice problems from these, okay?